So in this video, we'll try to find the derivative f prime of x based on the limit definition of derivatives. And I would like to emphasize it that you usually should learn a lot of standard rules to find the derivatives for different kind of functions f of x. But for now, we are trying to understand how to find the f prime of x based on the limit definition. And now let's try to do it together for this problem. Let's write down the definition first for f prime of x. Uh, so please think about it. At the top of the page, the first term is just the square root of x plus h, right? Because I'm talking about the function f of x plus h. You just have to replace x by x plus h, and for the first term, is really just the same as square root of x plus h, minus the second term is the same as f of x, which is square root of x. Now, if you pause for a little bit and just take h, just take h goes to 0. Let's say you take h equals 0, and you try to replace h by 0. You can easily see what's happening. When h is 0, the top and bottom are both zeros. And in this case, as we have done in quite a few times of examples that for the limit problems, when you see 0 over 0, we call it undetermined. It means that you don't know the answer yet, but you can get the correct answer by other appropriate methods. So let me repeat, 0 divided by 0 is not an answer. You cannot say the answer is 0. It doesn't have to be. It can be 0, of course, but you can only find it by an appropriate method, depend on the problem. So now, for the current problem, we have the radical, and we have to try our luck a little bit, because whenever we have a radical, we can try to multiply the top and the bottom of the fraction by a conjugate of the radical. Conjugate means you look at the term that involve the radicals. I can multiply top and bottom by the same term, but you change the sign from negative to positive. So I don't think the bottom is going to change that much. I'll keep the bottom unchanged. How about the top? You see the top? Really like a minus b times a plus b, right? And a minus b times a plus b, there's a famous identity about it. It's a squared minus b squared. So we can apply this algebraic identity to the top. And the first term is a squared, and the a is the same as the square root of x plus h. And the second term is square root of x as the b, and it is square root of x. Now we'll try our best to simplify these fractions. So the bottom is the same. But the top we can simplify slightly because square root, you see square roots and square cancelled. Also, the square root and square cancelled each other. So we actually have x plus h minus x like this. And you see the x is cancelled in the numerator side. So the next step, we can simplify the numerator. The numerator has h divided by a big term. And now, of course, you can cancel out the h as a common factor for top and the bottom of the fraction. So after cancelling the h, we have a simplified fractions, which is 1 over square root of x plus h plus square root of x. And I think it's quite safe, at least at this point, we can say that we can just replace h inside the fraction by using h equals 0. And this fraction is the same as 1 over 2 times square root of x. So it means that the derivative f prime of x is actually 1 over 2 times square root of x. And once again, as I said at the beginning of this video, This answer can be obtained by other differentiation rules, and by using these rules, it's gonna be much easier and more convenient for you to get the answer of f prime, which is the derivative of f of x, for many other kind of functions. But in this video, I'm just going to show you, well, to get the derivative f prime, we can actually just use the limit definition of derivative.